Hi Calculus! Welcome to section 3.7, where we introduce the chain rule, which is used to find derivatives of composite functions. The chain rule can be written in multiple ways. We can say if y is a function of u and u is a function of x, then dy dx equals dy du times du dx. Or we can say if f of x equals g of h of x, then f prime of x equals g prime of h of x times h prime of x. I personally prefer it verbally, so I'll usually refer to it this way. I'm going to say we're going to differentiate the outside function with respect to the inside. So we're going to leave the inside the same. Then we're going to multiply this by the derivative of the inside. So basically, a lot of people like to say the derivative of the outside times the inside, but times the derivative of the inside. It's going to make more sense as we look at a couple examples. The first example is to find the derivative of y equals cosine of t squared plus 1. You'll notice that this is a composite function because we have the cosine part, and then our inside is t squared plus 1. So to look at this one piece at a time, to find our derivative, we're going to find our derivative, y prime. So first we're going to take the derivative of the outside. The outside is what we'll refer to as just the cosine part. The derivative of cosine is negative sine. When we take the derivative of the outside, we're going to leave the inside the same. So the derivative of cosine is negative sine of t squared plus 1. Now we need to take the derivative of the inside being t squared plus 1. The derivative of t squared plus 1 is 2t. So we can think about this as the negative sine is the derivative of the outside times, this is our original inside, and 2t is the derivative of the inside. Let's look at another example. Sometimes we're actually going to have to apply the chain rule more than once. For example, if we have y equals sine of 5 minus sine 2t, we actually have two composite functions there because our inside has its own composite. We're going to do the chain rule 2 times in a row. So let's find the derivative. Once again, we're going to start by finding the derivative of the outside. So the derivative of sine is cosine. We're going to leave the inside the same. 5 minus sine 2t. So this is my derivative of the outside. Here's my inside. Now we have to multiply it by the derivative of the inside. So the derivative of 5 is 0 minus the derivative of sine is cosine. And here's where we have our composite function. So cosine is really the derivative of, again, another outside. So we're going to leave the inner part the same. Then we need to multiply by the derivative of the inside. My new inside is 2t. The derivative of 2t is just 2. So really we can say that this is the inside number 1. This is the derivative of inside number 1. And 2 is the derivative of inside number 2, as inside number 2 was just 2t. I hope you understand the chain rule. Thank you very much. Bye.